I welcome you all to the module 6. Module 6 is titled as Thinking and Intelligence. So, this is a module where we will talk about the different aspects of thinking, types of thinking, and then one related concepts related to thinking is intelligence. So, this module will deal with these two major concepts, thinking as well as intelligence. Today's lecture is lecture number 14 and this is the first lecture of this module, and today's lecture is basically titled as Thinking and Problem Solving. So, this lecture will specifically focus on the concept of thinking and how we solve problem using thinking. So, before we talk about today's lecture, let me give you a brief recap of the last lecture. So, the last lecture was lecture number 13, which was part of the earlier module on memory. So, in that lecture we discussed the concept of forgetting by using the concept of forgetting curve and various theories of forgetting, and we also discussed various applications of the concepts of memory to improve our memory. How can we use a lot of this concept that we discussed in terms of improving memory in the real world context. So, these are the things that we discussed in the last lecture. In today's lecture, we will focus on some of the key concepts such as thinking, what is the meaning of thinking, what are the contents of thinking, what are the different types of thinking, how we use thinking to solve problems. In that context, we will talk about the role of creativity in solving problem, and at the end we will talk about some practical applications in terms of how to increase creativity and so on. So, let us start today's lecture. Okay. So, let us start with the concept of thinking. So, because this module is about thinking, so how do we define thinking? Now, thinking is one of the central concepts in one of the major branch of psychology, which is called as a cognitive psychology. So, it is a particular branch of psychology that studies how human acquire, process and use knowledge about the world. It focuses on mental activities such as thinking, information processing, language use and problem solving. So, cognitive psychology more specifically focuses on this whole idea of thinking and the various aspects related to thinking, like information processing, language, decision making, problem solving and so on. So, the term cognition that we use for cognitive psychology, it comes from this Latin word cogito, meaning to think. So, thinking is central to cognitive psychology. So, thinking, many times used as a synonymous to cognition, is generally defined as the process of representing and manipulating information in the mind. So, there are two important aspects to this definition. So, it is a process. When we think, it is a process. One aspect of it is representing and another is manipulating information. So, we represent certain information in the mind and then we manipulate those information. So, that is the process of thinking involves these two important aspects. So, represent means you just create certain forms of content like images or concept. So, that is the representation part of it, and then we play around that, process those or manipulate them, connect, link one concept with another concept. So, that process of manipulating those information, first representing and then manipulating those information, this is what thinking is involved. It is very similar to what a software does in a computer. So, we have a content of thinking that we will talk about what are the contexts, more specifically the images and the concepts, and then we manipulate those content. Whatever images we form in our mind, we play around that, we kind of make relationships, connections and so on, or the concepts that we have in our mind. So, that process of representing information and manipulating information, that is what thinking is involved. So, thinking involves these two important aspects. Now, as we said, thinking involves representing information. So, in that sense, we are talking about contents of thinking. What is the content of thinking? When we think, what is the thing or the content that we manipulate when we think about something? So, units of thinking or contents of thinking is something, the basic ingredient of thinking. Then we manipulate those ingredients. So, contents includes two major contents. One is called as a mental images, another is called words or concepts. One form of content that we use for thinking is imaginations or images, and second important content or the form of the content is mostly the language, we use the language, that is words and concepts. For example, we use the word like, it could be very concrete form of concept such as chair, table, or it could be very abstract kind of concept like truth, beauty, and so on. Okay? So these are all concepts in our mind, and we use these concepts to think about something in the world. Okay? So one is word and concepts, mostly language is involved in it, and another is images. So these are the two important contents when we think about anything. So thinking involves these two important contents or units of thinking. Now let us look into each of them little bit in more detail. So thoughts as images, when we think, one of the important content is images, as we said. So let us look into these images. A lot of people, when they think in terms of pictures, or in terms of you are using images. So that's called thinking in a picture. A lot of people, such as Temple Grandin, who was a college professor who had autism spectrum disorder, he described her thinking style as a thinking in picture. So a lot of people use images as a very important aspect in terms of thinking. Similarly, Albert Einstein was known to use a lot of imaginations or images while, or visualization while, when he used to solve a problem or think about something. So Albert Einstein reported that he relied heavily on mental visualization in the early stages of his thought processes, translating those ideas into words later on. He started with the imaginations or images, then he used to translate those thinking processes in the words later on. So a lot of people, a lot of our thinking could involve images, which may include, we also call visualization and imagination and so on. Basically the content here is images. What is a mental image? Is a mental picture. When we say an image means what? It's a mental picture or representation of an object or an event reconstructed from the memory rather than photographic copy. So whatever we see in the world, we know what is the shape and color and so on. We can recreate those objects in our mind, then it becomes a mental image. We try to represent a lot of things that we see in the actual world, or we can also imagine things which are not actually, which don't exist in the world also. So we can create mental images or pictures, or these are also mental representations. So people can form mental images of faces, familiar places, letters, events such as graduations or religious ceremonies, etc. We can create mental images of whatever we see in the world, or even whatever we don't see also. We can kind of create things which don't even exist. So these images help us perform various cognitive tasks. For example, recalling directions by visualizing landmarks like a church or a gas station instead of relying solely on verbal descriptions. So a lot of our thinking processes involve this kind of images and imaginations and visualizations, and they help us to perform a lot of different cognitive tasks that we do on our daily basis. For example, when we recall directions, we may create whole images of a particular landmark or a particular road, and we can kind of understand I should go in this direction, that direction. We have full images of a lot of these pathways and the maps and so on. So we use many times a lot of images that we see and recreate those images in our mind to do a lot of actions in our day-to-day life. So mental imagery also plays a very key role in creative thinking and problem solving. So when we creatively think on solve a problem, imaginations plays very important role. Again, the famous case of Albert Einstein, who often relied on mental imagery and thought experiments to develop his ideas. A lot of his ideas that he developed in the physics, he kind of used a lot of mental imagery and thought experiments to develop those ideas. His famous theory of relativity originated from visualization at age 16 of riding alongside a beam of light. So what he said, so a lot of these ideas, especially the concept of theory of relativity, also emerged out of his visualizations of a lot of things that he, in terms of how he thought about a lot of these theories. Like he was imagining riding alongside the beam of light that led to this idea of relativity. Einstein noted that words came only after images, emphasizing that his creativity began through visualization. So, a lot of these creative ideas actually came out of visualizations. So, many times people solve problems or a lot of creative ideas emerges as a result of visualizations or using images. So, research shows that people treat mental images like a real objects. So, for example, I can see a real object like a chair or a ball. I can similarly create the same image of that object in my mind and play with it just like the real objects. We can rotate the object, we can zoom in, we can inspect just like the real object we can do. A lot of these actual characteristics that we can do in the real objects, we can also do with the same in our mental images also, you know. For example, imagine you are asked to mentally picture the map of India and answer this. Count cities between Delhi and Chennai, then count cities between Delhi and Jaipur. Okay? So, this is a map. We can create a mental image of India, map of India, and we have some ideas about where the different states lies. And if let us say somebody asks you, count the number of cities that comes between, let us say Delhi and Chennai, and then again you are asked to count the cities between Delhi and Jaipur. Most probably for most of the people, you will likely to take more time counting cities between Delhi and Chennai, because the distance between Delhi and Chennai in the map and the real world is much more, and the number of cities also comes the number is much higher, because the distance is very long distance. The distance between Chennai and Delhi is very high, or the distance is quite long as compared to Delhi and Jaipur. So, you are more likely to answer the number of cities between Delhi and Jaipur as compared to Delhi and Chennai, as if you are actually physically looking at a map. So, the lot of these actual pictures and the mental pictures, the characteristics are almost similar. Okay. So, thinking often involves mental images that behave like real world objects. You will answer almost like you are looking at the actual map when we create a mental image of a map. Children appear specially to rely on visual images. If you look at children, initially their reliance on the visualization or the visual image is very high. In terms of when they think, a lot of images are involved in the thinking process of a child. For example, in a classic study by Havard and Haber in 1960, found that 2 to 15% of elementary school children could recall detailed, long-lasting visual images of a complex picture which was viewed briefly, describing it as a still seeing it. They could, a lot of these children could actually accurately describe the different complex images that they were shown very brief for the brief period of time, which is also called eidetic imagery. However, such vivid visualizations are rare in adults, but as we become more and more adults, or as our age progresses, a lot of this imaginary capability of imagination or thinking in terms of imagination seems to decrease because of the development of languages. Then we rely more on language, more on concepts, more on abstract ideas in terms of thinking and less with the images. So, that is a general pattern which may not be true for everyone, but this is what is a general pattern. So, children uses more images in their thinking, adult uses more of a concepts that we will discuss now. So, as language becomes more dominant during development, it may begin to interfere with or replace direct visual forms of thought. So, language kind of takes place a lot of the visualization that we used to do earlier because of the development of language. Okay. So, mental imaginary, when we talk about, obviously the most dominant could be the visual images, but it is not necessarily only visual. We can have a auditory image, we can have a tactile image like touching, we can have an gustatory image, tasting, olfactory experiences, how it smells, we can recreate it in our mind, how we, what was the same smell of certain objects. Okay? So, we can have images of all the sensory organs, not just visual. Visual is most dominant. So, for example, people can mentally hear opening chords of music like Beethoven's 5th Symphony and so on. Whenever we hear music and so on, Later on we can mentally almost hear what we have heard about certain music and so on. So, that is also a mental imaginary, but it is, you are not creating a image of it, but image in terms of not visual image, but actually auditory image. We can also taste a fresh strawberry or feel cotton brushing the skin. However, visual imagery tends to be the easiest and most common form. So, we can also create smell of things, taste of things. We can also hear sounds and musics. So, when we talk about images, we can create images of all types of sensory organs. Obviously, the visual form is most dominant. In contrast, abstract concepts such as justice, honor, liberty are better represented verbally and conceptually rather than visually, since they lack concrete sensory forms. When abstract concept comes, such as concept of truth, concept of beauty, concept of liberty, concept of justice, they do not have a clear cut form of or shape. These are abstract concepts. Then we need to use conceptual forms. Then the thought or thinking process, the content is a concept. There is no boundaries or shape that we can imagine. So, then obviously the thinking process involves abstract concepts and ideas and so on. So, ultimately, regardless of whether your mental representation are visual, verbal or otherwise, effective thinking requires organizing knowledge into concepts. Okay. So, we become the more complex forms of thinking requires you to organize all the knowledge into conceptual forms. Even if you imagine something, ultimately you have to translate it in the words and concepts. So, you have to organize whatever you think, imagine, visualize, whatever it is. Ultimately, you have to organize those knowledge into concepts, abstract ideas that allow us to categorize and make sense of the vast information we experience, that help us to make sense of the information that we get or whatever things we see in the world. So, ultimately it has to be in the conceptual form. So, there comes thoughts as a concepts. So, we have talked about how images or visualization plays very important role in our thinking process. Now, let us look at what is the role of concepts, because that is the most probably the dominant aspects of thinking. So, what is a concept? So, concept means these are mental categories that allows us to group objects, events or ideas based on shared characteristics. Okay. So, concepts are certain, you can say, mental categories that we develop when we group certain objects together or events with certain characteristics or ideas based on some of the shared characteristics. You say this is a group of, for example, we classify moving objects as cars or trucks and classroom items as, let us say, chairs, tables, students, like this. These are all concepts that we develop based on the different types of objects and categorize them, organize them, group them and so on. This process helps us to organize and interpret information efficiently. You do not have to individually look at lot of these items. So, let us say, when we see a moving object, let us say, we do not have to process each and every moving object. We say this is a car or this is a vehicle which moves. So, we can categorize all the moving objects in one category. So, it helps us to organize information efficiently. Otherwise, each and every object has to be placed in certain memory and with certain different characteristics. But if you categorize all of them in one category, you know what is the meaning of a car. So, most of the things will come in one category. So, that help us to organize process information more efficiently. So, these are the meaning of concepts. So, concepts are very important. Concept formation plays the major role in our efficient functioning in the real world. So, forming concepts enables human to anticipate and respond appropriately to the situation. It is because of the concepts that we have, we are able to appropriately respond to situations. For example, recognizing a slithering creature as snake help us keep a safe distance, surviving advantage that prevents harmful mistakes. For example, we have a concept of snake as an animal which can be dangerous. So, we all have a concept of snake and it can be dangerous. So, the moment we see a snake, automatically we know what to do. we know what is the appropriate behavior. We keep a safe distance because we know it can be dangerous. So, once we learn a concept, we don't have to look at every snake whenever comes, we don't have to think and process it. We know as a group of snake, it can be dangerous. So, automatically help us to respond appropriately to that situation. You don't have to process every time you see a snake and again process it, because you have a concept of snake. So, without the ability to form concepts, every new experience would be confusing and unpredictable. So, if you don't have a concept of snake, every time you see an object, you don't know how to behave. But if you have a concept of snake, whatever snake comes, you know how to behave. We don't know whether a barking four-legged creature should be petted or feared. For example, we have a concept of a dog. When it is barking, it's a four-legged. So, we have a concept of a dog as an animal. So, we know how to behave or respond to a dog. So, we have a concept of a dog and its behavior and so on. So, we don't know whether a round object should be eaten or played with and so on. So, all these ideas that we efficiently organize and automatically process information without thinking much, because we have a concept around those things. So, this helps us to respond appropriately. Concepts speed up our responses. Because of concept, we don't have to think much, because I know this concept, so this concept I know how to behave. So, I don't have to think again and again and again. So, it helps us to speed up our responses. We don't have to relearn every time new information comes when you have a concept around it. So, for example, once we understand the concept ambulance, we immediately know to pull over when one approaches. We know ambulance and what is the meaning of ambulance, that this can be an emergency situation. We know around what is the concept around ambulance. So, the moment it comes, we know we have to give a space to the ambulance and so on. So, because of that concept formation, we know how to behave appropriately. So, concept formation help us function efficiently in our daily life. So, that's something very important. So, we think, a lot of our thinking process involves playing around concepts, manipulating concepts, connecting concepts. So, one way of thinking is we manipulate images or visual or whatever images we have. Another is we play around concepts. Thinking involves playing around with the concepts. When we talk about concepts, there are two main types of concepts we deal with. One is logical concepts. So, logical concepts have a very clearly defined rules for membership. For example, any figure with three sides is classified as a triangle. This is a very logical concept. Concepts with clearly defined rules. For example, the concept of a triangle, concept of a square, concept of a rectangle, very clearly defined rules are there. What is called as a triangle, what is called as a rectangle. So, those rules are very clearly defined. There is no playing around that, So, those are called logical concepts. However, there is another category of concept called as natural concepts. So, natural concepts are not very logically defined. They are kind of contrast to logical concepts. So, they are also called fuzzy and less strictly defined. Most everyday abstract ideas such as the concept of justice, honor, freedom fall into this type of natural concept category, because their boundaries and meanings are very fuzzy and everybody may define them in their own ways. So, there is a lot of subjectivity involved in it. So, that is called natural concepts. These are fuzzy concepts. Boundaries are not very clearly defined. How do you define justice? How do you define freedom? How do you define beauty? Everybody may have their own definitions. So, the boundaries are not clearly laid out. So, those are called as natural concepts. So, we use sometimes logical concepts, sometimes natural concept in our thinking process. People also often use concepts in daily life without really understanding the precise meaning. When using concept, not necessarily every time we have to know the precise meaning of every concept. We can have a broad idea around it. For example, most people easily identify an apple as a fruit. Okay? Anybody can say that apple is a fruit. So, it comes under the concept of fruit, but may hesitate when considering whether a pumpkin, avocado or olive, whether this comes under fruits or not, though botanically they are all fruits. So, many times we have some prototypes or examples of fruits which are very commonly we say these are all fruits, but some fruits which can be technically fruits, but we may not actually know that they are actually fruits. One example is pumpkin, avocado or olive. They also qualify as fruits from the scientific perspective, but a lot of people generally may not consider them as fruits. So, sometimes we can use these concepts in a very loose sense, but they serve the purpose in our daily life. So, botanists for example define fruits as the ripened reproductive part of a seed plant, making it is a logical concept when scientifically we look at it. They have a very clear cut definition of a fruit with a clear rules. However, in everyday use fruits function as a natural concept, but when we use this concept in a day to day life, it is very vague and there is no clear cut boundaries, but scientifically they have a very clear cut logical conceptual definition of a fruit, but in real life it is a natural concept. People use it in a very fuzzy way. So, we have logical concepts, we have natural concepts, but in real life lot of concepts can be logical, but we use them as a natural concepts because we do not know the actual boundaries of those concepts. So, though all these possibilities are there. People often apply natural concepts by making probability judgment. When there are we do not know the boundaries or actual clear cut conditions of a concept, then we use probability judgment. We see probabilistically does it fit into that, then we say this is this concept. Probability judgment, estimating how likely someone belongs to a category. To do this, we compare the new object with a prototype or the best example of that category. Many times we have a typical case of a particular category, and whenever we see a new object, we kind of compare this with the typical example of a particular category, which is called as a prototype. If that matches, we say this comes under this category. We just use some probability estimates. For instance, for example, many people regard robin as a prototypical bird. So, when we use the concept of bird, few birds become prototype, like these are typical example of how a bird should look like. One example is robin bird, where is the small bird. Whenever we hear the word bird, lot of this prototype of robin bird comes into our mind, that a bird should look like this, the concept of bird. So, typical example is a robin, for example. Consequently, we are more likely to classify sparrow as a bird because sparrow looks very similar to robin. So, prototype example of a bird is robin, and when we see a sparrow, automatically we say this is a bird because they look exactly same or similar. But when we see other birds like ostrich and penguin, we may find it difficult to classify them as bird because they do not fit with the prototype of a bird, but still scientifically they are bird. So, many time in real life we do not use very specific definitions or criteria of some concept which may exist, but we may not know, but in real life we use lot of time probability judgments to categorize some objects as under certain concepts. So, the example we gave here. So, logical concepts depend on strict definition, as we said. Natural concepts are based on, we lot of time conceptualize a particular thing under a natural concepts based on similarity, probability, prototypes and so on, and experience, reflecting its a flexible intuitive nature of human categorization. So, when we categorize things under natural concepts, it is very flexible, it could be very intuitive based on similarity, probability and experience and so on. So, things could maybe much more fluid when we talk about natural concepts. So these are the two important contents of thinking. When we think in terms of images and we think in terms of concepts. So these are the two important contents of thinking. Okay. And we have discussed some of the characteristics around that. Now let us look into what are the different types of thinking. When we think, we can think in a particular way. So that is the meaning of type of thinking. When we think, our thinking process can have a particular direction, a particular process that may lead to certain types of thinking that we are involved in. So when we say thinking, typically what we said is it's an internal mental process of manipulating information to form the concepts, solve problems, make decisions, engage in reflections. So using thinking by manipulating information here could be an images, could be a concepts. So these are the contents of thinking. We manipulate those contents, and using those contents, manipulating those concepts, we form further concepts, solve problems, make decisions in our life, we reflect on things and so on. So everything around thinking happens because we manipulate those contents of images as well as concepts or words and so on. So the example comes when you talk about thinking. If your brain were a computer, thinking would be a software running the data. It's how we bridge the gap between receiving information through our senses and actually doing something with it. So when we receive information using sense organs, so they are like data points. We receive a lot of information from the real world. So these are data. So for every software, we provide them some data, and then the software manipulates those data and creates certain outputs. So thinking is just like software. It receives data from the real world, and then it manipulates those data and gives you certain output. Like you solve a problem, so that's an output. So thinking is like with a similar analogy, thinking like works in a very similar fashion. So what are the types of thinking? We can think in various ways. Some of the broad categories may include convergent thinking, divergent thinking, and metacognition. Let us look into what are these types of thinking. So convergent thinking, as the definition, as the name suggests, we think in such a way that we converge on a point or a solution. So convergent thinking involves focusing on finding one correct or best solution to a problem. Generally, when we want to solve a problem, we use thinking. Most of the time we use thinking to solve problems. But whenever we need a particular specific solution to a problem, we use most of the time, convergent thinking. We take all the data and then we converge to find how to solve it. So that focusing on finding a correct or best solution to a problem is convergent thinking. Convergent thinking relies on logic, rules, and existing knowledge used in exams, problem solving, and scientific reasoning. Okay. Whenever we solve problems, whenever we write an answer in an examination, these are all convergent kind of thinking. We have information, then we write about it to give a solution. When we solve a mathematical problem, so it's a convergent thinking. We are using whatever knowledge we have to find a solution to a problem. So these are all convergent thinking. So in convergent thinking, what we do, we narrowing ideas to reach a single right answer. We narrow it down. Using all the data, we try to find and narrow down to find a single answer. So examples includes varieties of things that we already talked about, like a student solving a math problem, like what is 24 into 6, any kind of such kind of problems will come under convergent thinking. A detective narrowing down clues to identify the suspect, a detective using all the evidences and trying to find out who is the real suspect. So that is also a kind of convergent thinking. Another kind of thinking is called as a divergent thinking. As the name suggests, this is a kind of opposite to convergent thinking in terms of style of thinking. So in divergent thinking, it is typically used in the creative thinking process, creative problem solving. So creative and open-ended. It involves generating many possible ideas or solutions for a single problem. So in in divergent thinking, you start with one thing and you diverge, find multiple solutions, multiple ideas around a single concept. So, in convergent, from multiple ideas you come to a conclusion. So, that is convergent thinking. In divergent thinking, it is more open ended, and you find, let us say, solution of a problem, multiple solutions. You go from one idea to multiple ideas. So, that is called divergent thinking, and divergent thinking is a hallmark of creative thinking. People become creative by thinking divergently. Divergent thinking is the basis of creativity, imagination and innovation, because you find multiple solutions. Some of the solution could be very different from the traditional solutions. So, that gives newer ideas. Divergent thinking leads to expanding ideas in many directions. For example, thinking of different uses of brick. So, if you generally say what is the use of a brick, people will say it is used to construct house. That is a traditional typical convergent thinking. But when you use the same concept, what is the use of brick in a divergent way, let us say use the divergent thinking here, you can say brick can be used for doorstop, paperweight, garden decor, etc. Now, these are not traditional answers, but these are all can also be the uses of brick. So, the person is thinking in a divergent way, multiple solutions. So, that is an example of divergent thinking. So, brainstorming ways to reduce school waste, for example, how can we reduce school waste? Recycling bins, what are the ways? Compositing, awareness drive, etc. These are all examples, multiple ways of, lot of time brainstorming that we do are basically divergent thinking process. You try to find multiple solutions of a problem. So, these are all examples of divergent thinking, and creativity comes from divergent thinking. Another form of thinking that is called metacognitions, which also means thinking about thinking. So, many times we not only think, we also sometimes thinking about how am I thinking. So, thinking about thinking. So, it is a kind of meta perspective. So, metacognition means thinking about thinking. In the other categories, you are just thinking about something. Here, you are thinking about how you are thinking. So, that is called metacognition. It is the ability to monitor, control and evaluate your own thought processes, knowing how you learn, remember and solve problems. It is you are making or thinking about your own thought processes. Metacognition means it is an awareness and regulation of your own thinking. You become aware how you are thinking, is it good, is it bad, am I thinking in the right direction. So, you are thinking about your own thinking, and you are also regulating it. I think I am not going in the right direction, I should take this way to solve the problem. So, this is a metacognition. So, for example, a student realizes I understand better when I draw diagrams instead of reading text. This is an example of metacognition. The student has an insight about his own style of thinking, that I think better if I do this as compared to this. So, it is thinking about his own thinking process. For example, after taking a test, thinking next time I will start with easy question and save time. So, you are basically looking from a broader perspective how you have done something, and you are analyzing your own thought processes. So, these are all examples of metacognitions. So, this is about some of the different types of thinking. Thinking can be in the form of convergent thinking, divergent thinking, sometimes thinking can be metacognition thinking, thinking about your own thinking. So, now let us come to the concept of problem solving. The problem solving is directly connected to the concept of thinking. By using thinking only we solve the problem. For example, we have discussed we can use convergent thinking, divergent thinking to solve a problem. Most of the problem solving involves convergent kind of thinking. Creative problem solving may require divergent kind of thinking. So, thinking is associated with problem solving, you cannot separate them. So, that is why we are discussing both the concept here together. So, one of the main function of particularly convergent thinking is to solve problems, to bridge the gap mentally between a presenting situation and a desired goal. So, when we want to achieve some goal by using certain information, then we try to solve the problems to reach the goals. So, problem solving is a cognitive process that involves using mental strategies to find solutions. So, whenever we use certain strategies, mental strategies to solve or find a solution or reach a goal, then it is called problem solving. So, there is a problem and you want to solve it using mental strategies. So, those are called problem solving. So, problem solving is a very specific application of thinking and is goal directed. So, basically when you apply your thinking in a particular direction, so it is an application of thinking to solve a problem or to reach a goal. So, it is an applied aspect of thinking. So, you are using your thinking process to find a solution, find a or reach a goal. So, that is called problem solving. For example, one of the earliest studies on problem solving was conducted by Edward Thorndike, who replaced animals in a puzzle box, who placed animals in a puzzle box and observed that they used trial and error, which is also called hit or miss method, until they accidentally perform the correct action. So, even animals, when they put in a puzzle box, they do trial and error kind of. Sometimes they go find a wrong step, then they understood this is not the right way, then they try something else. So, that is called trial and error. You do something and you find, then it does not work, then you try something else, and if that does not work, you something else. Like this, you do trial and error, and finally you find the right kind of solutions. Even animals can do that. So there are different types of strategies people use to solve problems. There are different varieties of strategies. Problem solving is a kind of mental strategy. So, what kind of strategy we use to solve a problem? So, there are different strategies. One is trial and error, which is very commonly used by people. When you do not know the solution, you use trial and error. Do something, if it does not work, do something else. If that works, you go to the next step. So, that is called trial and error. So, trying different solutions one by one until you find whatever works. It is also called as a hit or miss method, often used when there are limited options or no clear rules. When you don't know, when you don't have much knowledge about the solutions, when you don't know the rules, when the options are very limited, people generally use trial and error, because you don't know how to solve a problem. So, in that case, the only solution or way you can go ahead is to use trial and error. For example, as we give examples, the rat in the Thorndike's puzzle box presses various levers until he finds the right lever. When it is pressed, then the door opens and they can go out. So, even animals also can use this kind of trial and error method. In everyday life, you might try several keys on a keychain until one unlocks the door. For example, you have a lock and you have a bunch of keys. You don't know which key is the right key for the lock. So, we use trial and error. We start with one, if it fits, then if it does not fit, we use the another one and something like that. So, this is a typical case of trial and error. So, that is one way we try to solve problems. Many times when the rules are not very clear, we do not have much knowledge about something, then we use trial and error. Another way we solve a problem is through many times we solve a problem using insights. What is an insight? Insight is a sudden realization or aha moment when the solution appears all at once rather than through step by step reasoning. Many times you are working on a problem and you are not able to solve that problem. Then suddenly you find a solution as an insight. It comes suddenly, not step by step. You have been doing everything, but it is not, nothing was working. Then suddenly insight comes and you find the solution in one moment. So, sudden realization of solution, that is called the insight as a way to solve a problem. Insight occurs when the problem is restructured in the mind. You suddenly see it from a new angle. So, you have been trying to do in certain ways, but it was not working. Suddenly in your mind you realize I can do it in that way and it works. So, from a different perspective you look at it because you have been struggling with that. For example, when you suddenly realize how to fix a malfunctioning gadget after thinking about it for a while. You have been trying, you could not fix the gadget, but suddenly you realize, I can do this, and then it works. So, that is an example of insight as a problem solving strategy. Then another strategy to solve problem is called algorithms. Algorithms are whenever we use very step by step process, you know, a lot of this actually computer solves most of the problems using algorithms only. You give the rules and it follows those step by step process and gives you solutions. So algorithms are systematic step by step procedure that guarantees a correct solution if you follow it properly. If you follow the step, there is a guarantee that the solution will be reached. So that's why computer can solve problems, because the rules are very clear cut and it follows it step by step. Ultimately the solution will come. So when we use step by step systematic process, rules are very clear and you have to follow those rules, then solution will happen. Algorithms are logical, rule based, but they can be time consuming because there can be exhaustive time may be required. That's why when human use algorithm, probably it may take a lot of time, but computer can process it fast. So that is why it is more efficiently done in there is a fast processor and so on. So for example, in mathematics, using long division method is an algorithm. It always produces correct answer. So in mathematics, whatever we use different types of process to solve a mathematical problem. Process is very clearly defined. If you follow that process, the result correct solution will come. There is no doubt about it. But if you miss some steps, you will not end up in the right solutions. So a lot of these mathematical steps, how we divide, how we multiply. So there are steps, rules involved in it. If you follow them, you will get the right answer. So these are examples of algorithms. A computer program, these are all algorithms that test every possible password combination until it finds the correct one. Also uses an algorithmic approach. Okay? So most of the computer things are actually algorithm based solutions that they provide for problems and so on. Another way people solve problem is using heuristics. Now heuristics are like mental shortcuts. We human use it very often, you know. So we use the shortcuts. Whatever we have some experience, based on that we use shortcuts to solve a problem. We don't go step by step because it takes a lot of time. So heuristics are mental shortcuts or rules of thumb that help solve problems quickly, but without guarantee. In algorithm there is a guarantee because you are using step by step. In heuristic you are not using step by step, you are using some shortcuts based on your experience, but there is no guarantee that using heuristic you will solve the problems. It takes less time, but then it can be errors in the solutions. So they are efficient but prone to errors. So psychologists have identified certain types of heuristics that we use to solve problem. One is like availability heuristics, another is called representative heuristics. What are these? So availability heuristic means what? Judging likelihood or frequency of an event based on how easily examples comes to your mind. If something comes to your mind, quickly you try to use that rather than using step by step process. If something is easier to recall, we assume it's more common or more likely to happen. For example, after seeing news reports about airplane crashes, people may overestimate the danger of flying, even though car accidents are far more common. Because now it is in your memory fresh. Some accidents happens, let's say flight accident or airplane accidents. Then after that certain time period, people overestimate the danger of flying. They think the flights are going to crash because of this availability heuristics, because this memory is very fresh. Whenever you think about flights, that crash comes to your mind and you think it may also crash. So we overestimate the likelihood of crashing, even though car accidents are the most common. Highest number of people actually die using car accidents and so on. So this is an example of availability. Many times we take decisions based on whatever is fresh in your memory, whatever comes to your memory quickly. So that is way of solving problems. For example, a teacher may believe students are often late because few examples of late stand out vividly in memory, because few students came maybe recently late, so you think students are late, most of the students are late, which may not be the case because only you have fresh memories of some late cases. So like this influences your decision making, and whatever path you take, whatever way you solve a problem, it can be influenced by these heuristics, mental shortcuts you are not using step by step and actual data processing here. That is why you are taking shortcuts here only, because you don't have, you are not considering how many airplane has crashed, the numbers are very less, and if you compare with the number of accidents that happens by car and so on. So, if you use systematic processing, you will have data and then you will see that is not the case, but you use mental shortcuts, whatever comes to your mind you think that is going to be the case. Representative heuristic is another shortcut that we take based on how similar it is to a typical prototype of a category rather than using actual probabilities. For example, if someone is quiet, reads a lot and wear glasses, you might guess they are librarian rather than a salesperson, or maybe a academician rather than a salesperson, because this kind of imagery, or somebody is quiet, reading, wearing glasses, this is a prototype of somebody who is related to studying a lot or maybe something research and so on, rather than let us say somebody is a salesperson, because they fit the stereotype or a prototype of a librarian or a student, whatever it is. So, sometimes we decide or we take certain decisions, certain directions simply because of certain representative heuristic shortcuts we take without really analyzing the situation properly. So these are like the different ways we solve problems. We solve problems particularly convergent kind of thinking process for solving problems. We use trial and error method. We sometimes insights comes for solving problems. Many times we solve problem using algorithms. Sometimes we use heuristics to solve problems and make decisions in our life. Okay. And this is very common. Heuristics are very common among human beings, because step by step it takes a lot of time and energy which we do not want to do. Now, let us talk little bit about creativity and problem solving. Now, sometimes a lot of the cases that we discuss, these are all convergent kind of thinking and coming to a solution. Many times we need, let us say, multiple solutions, or creativity requires different types of thinking process, which is called as a divergent thinking process. We do not have to come to a convergent idea, but we need multiple ideas. So, creativity also is used to solve problems, but the types of thinking is very different. So, creativity refers to ability to generate original ideas or solve problems in novel ways. Here you do not have to just solve problems, you have to solve problems in a original newer ways. So, the requirement is different here in terms of solving problems. So, cognitive psychologists have long explored why some individuals are more adept at finding innovative solutions or creative solutions than others. Why some people are more creative in terms of solving problems as compared to others, why this happens. So, while creativity is easily recognized, its causes are harder to define. It is very difficult to find why somebody is creative, what is the cause behind it. Creativity in the art and may differ from creativity in sciences. So, creativity, how it is expressed may also differ. In artistic domains, the creativity how it expressed may be very different than when it expresses in the sciences or scientific researches. In artistic, creativity may require different kind of visualization and so on. In scientific, it may require more of a conceptual thinking and so on. So, expression may also differ based on the domains of knowledge and so on. So, highly creative individuals tend to exhibit divergent thinking. This is something very commonly found among researchers, that people with high creative ideas they have more of divergent kind of thinking. It is an ability to produce unusually appropriate responses to problems. This contrasts with the convergent thinking as we discussed earlier. Okay. For example, what can you do with a brick, as we said, I think briefly touched upon that also earlier. People with a divergent thinking may give varieties of solutions. We can use brick to build a wall, use it as a paperweight, break it into pieces for art, use it as a doorstop, use it for self-defense and so on. These are all examples of divergent thinking. Typically, brick is not used for a lot of these things, but it can be used. Convergent thinking, people will mostly say the standard answer, use it for construction and so on. This is just an example of how convergent thinking is different from divergent thinking, and for creativity divergent thinking is very important. So, this is one thing for creativity. Divergent thinking is something very important for finding novel solutions. Creativity is also linked to cognitive complexity. What does that mean? It is a preference for elaborate and abstract thought. So, when people have more elaborative kind of thought processes, more detailed, elaborate, they prefer to think in that way, more detailed, elaborative way and abstract way of thinking. So, that gives them more cognitive complexity, and out of that complexity more creativity emerges. So, creative people often displays broad interests, independence and curiosity about philosophical or abstract issues. So, their interests are also broader, that is why they can connect with different ideas and find novel solutions. They are more curious, more abstract thought process oriented and so on. However, one interesting thing is that creativity is weakly related to intelligence. You do not have to be very intelligent to be creative. These are two different domains. Then the relationship, there is a relationship, obviously some type of intelligence is required, but the relationship is not very strong. Like you do not have to be a genius in terms of intelligence to be creative. So, that relationship is not very strong. So, traditional IQ test measures mostly convergent thinking, which is not required in creativity. But if you see the intelligence part and the tests that are used to measure intelligence, that we will talk about in this module also, these are typically measures convergent kind of thinking, and in creativity we require divergent thinking, which is not captured by the IQ tests. So, therefore, creativity and typical intelligence that we talk about are not very strongly related. Some level of intelligence is required, but you do not have to be a genius to be creative and so on. So, they may be very actually different. People of highly creative may not be very intelligent in the typical sense. Consequently, researchers find that creativity shows only a modest correlation with school performance and intelligence test. So, there is a very moderate or weak kind of relationship with the intelligence and so on. Now, at the end, let us talk about whatever we have understood. Can we increase creativity from whatever we have understood? What are the things that we should focus on to increase creativity in terms of solving problems or in a general approach to life? One important thing is to increase creativity is first is to build domain knowledge. Okay. You cannot be creative without knowledge. Knowledge is for the first requirement. You can be only creative when you have data and knowledge. Only you can then process those information in a creative way to find novel solution. If you do not know anything, how can you be creative? So, that is the basic requirement. To be creative is to build the domain knowledge. Requires knowledge and thinking skills, both are required. So, knowledge is required. Without knowledge, how are you going to think and process, find novel solutions? So, according to Robert Sternberg, expertise is essential for creative thinking. Deep learning in a subject increases innovation within that domains. Only people who have a lot of knowledge about a particular thing, they can be creative because they know ins and out and nuances in a particular area. So, they can look into novel solutions and so on. For example, a chef creates a new dish only after understanding ingredients and cooking methods. A chef suddenly cannot create a very original dish if he does not know how to cook, if he does not know the basic ingredients of cooking. That is not possible. A chef can be creative only when he knows all the details of cooking and ingredients and so on. So, the domain knowledge is very important. Second is obviously the divergent thinking that we talked elaborately in the lecture also. That is the hallmark of creative thinking, it is very strongly linked to creativity. So, to become creative, one need to think divergently, brainstorm without judging ideas, whether the idea is good or bad, do not judge. Sometimes silly ideas can lead to creative ideas and so on. Use least as many uses as possible of things and so on. So, like this, you brainstorming ideas in the divergent way help us to develop divergent thinking and makes us more creative. So, a lot of example, I think for divergent thinking we have given lot of examples. So, I will not go too much into that. So, that is a hallmark for creativity. Second is, a third important factors in increasing creativity is to reduce functional fixedness. Functional fixedness means what? When you become functionally fixed, means you only see only particular type of uses of something. So, you become fixed only, okay, this thing can be used only in this ways. So, inability to see new uses of familiar objects. So, you only see when you know certain objects, and in a certain context, you know this object is used for this object is for. So, you are fixated on that. You, whenever you see this object, you only think, okay, this object is used for these things. So, that is called functional fixedness. So, people become fixed on that. They are not able to see beyond that. So, that is one of the problem or obstacles for creativity. So, to go beyond that, you can ask what else can this be used for? Practice reframing problems. One of the very good examples of going beyond functional fixedness to find an innovation and creativity is an example of Dyson vacuum. It is one of the very innovative vacuum model that came up in the market. How did it come up? People generally believed a vacuum cleaner that is that people generally use must have a dust bag. So, all vacuums have a dust bag. So, and that is the general idea that people have, but when the bag fills with the dust, suction becomes weak. So, that was the problem. People were only thinking of how to make a better bag and bigger bag and so on. So, that is an example of functionally fixedness. People are only thinking about, so the bag is the problem, let us make it better, let us make it bigger and so on. What Dyson did, who developed this Dyson company and particularly this Dyson vacuum cleaner, he questioned this idea. He said, why do we need this bag? Can we do away with it? He used cyclone technology like the factories to separate dust. What was the result? No specific requirement of a large bag or something was done, because then cyclone technology was used. Strong suction all the time. It was not dependent on whether the bag was filled or not. The suction was strong all the time. So, a completely new type of vacuum cleaner developed because he went beyond the functional fixedness. Okay? He used divergent thinking. So, that is an example of how that helps. Then we also, the fourth factor which is an important requirement for creative thinking is cognitive flexibility, which also we touched upon. Its ability to switch between different ideas and perspective. How flexible you are in your mind to look into different perspectives. Creative individuals show greater flexibility in thinking pattern. So, that is called cognitive flexibility. Is about shifting between different frameworks, rules or perspective, and it is different from divergent thinking, which is about generating ideas from one starting point. So, cognitive flexibility is not about just divergent thinking, it is about shifting perspective. So, divergent thinking is about generating many ideas from the starting point. Cognitive flexibility is switching between different perspectives. So, they may be related to each other, but they are conceptually different things. So, how to improve that? Look at problems from multiple viewpoints, engage in interdisciplinary learning or knowledge from different perspectives. So, that helps you to look at things from the different perspective, which makes you more creative and so on. For example, a writer is stuck trying to tell a story from the hero's point of view. So, let us say the writer is trying to write a story from a particular character's point of view, let us say hero's point of view. Now, he is not able to, let us say, find a further how to go ahead with the story. If the writer is having more cognitive flexibility, probably he will take different perspectives. For example, if he is very rigid, there is no cognitive flexibility, then the writer may say, I can't figure out the plot, I am blocked. Let us say the story, he is not able to find out more ideas about story. If the writer has more cognitive flexibility, he may question, what if I tell it from the villain's perspective or a janitor's perspective? What if it is also told backwards or different time plots? Suddenly, there can be 10 stories hiding inside a same story. So, the writer is only changing his perspective. Same story told from the different perspective, it can create multiple stories out of it. So, like this it can become more creative storytelling and so on. So, this cognitive flexibility can also enhance your creativity and so on. The last point, which is about intrinsic motivation. A lot of time creativity comes when you are really internally interested in something. When something is forced, people are generally not creative in that. Doing something for interest, not for just reward, boosts creativity. If you are doing something just for reward and whatever reward you are getting, you are focusing only on reward and you will do whatever is just required. Creativity comes when you are really interested in something, intrinsically interested. Psychologist Teresa Amabile found intrinsic motivation is a key component of creativity. So, what is the idea? Choose tasks that you enjoy, avoid excessive external pressures or reward, particularly if you want to be creative in a particular directions. For example, a child drawing for fun creates more unique art than one drawing only for marks. That is a very clear, if you see, even if you give a child to draw something without any reward or any kind of foundations, child is more likely to create unique arts. Then let us say ask the child to draw only for exam and marks and so on. Then his focus is only to reward. Then the creativity decreases. So, these are some of the things from whatever we discussed can be applied in the real world context, particularly to enhance creativity. So, with this I stop here. Thank you.